Hi, as you can see from the graph, when we simply use the lower degree of polynomial such as 1, we will get the straight line. This shows the data is high bias. If we use the higher degree of polynomial such as 4 or 5 maybe, it will increase the complexity of the graph. It is high variant. When the hypothesis is in intermediate type of complexity, maybe degree of polynomial equal to 2, it will be just nice, not too high, not too low. Now, by using the training error equation, which is square error, we can get the error when we change the degree of polynomial. Okay, let's plot the figure. On the horizontal axis, I will plot the degree of polynomial, which means if moving to the right, it will go to higher and higher degree of polynomial. The vertical axis is for the error. Okay, from the previous example, when we select d equal to 1, the data is not too accurate with the straight line, meaning that there will be high training error. By increasing the degree of polynomial, it will make the complex polynomial graph. We can see almost all points is touch the line, thus reduce the training error. Let's transfer this to the graph. When d equal to 1, it will be higher training error. When d equal to 4, it will be lower training error and maybe reach 0. When d equal to 2, the training error will be just nice at the center of the graph. This is the final graph of the degree of polynomial with error. In the conclusion, when we increase the degree of polynomial, the training error will be decreased.
Okay, my name is Ahmad Shahir bin Zamari. I will explain about week 10 tutorial question number 2, diagnosing bias versus variance. The learning algorithm suffering from high variance because of the cross-validation error being high correspond to either this regime and this regime. So the regime on the left correspond to high bias problem, that is it if it fitting an overly low order polynomial when it need a higher order polynomial to fit the data. For the right side of the regime correspond to a high variance problem, that is the degree of polynomial was too large for the data set. So to distinguish between two cases concretely, for the high bias case, that case is the underfitting. Both cross validation error and training error are going to be high. So if the learning algorithm is suffering from a bias problem, the training set error will be high and the cross validation error will also be high. In contrast, if the algorithm is suffering from high variance, then the training error going to be low, and whereas the cross validation error will be much more than the training error. Okay, thank you.
Good evening, everyone. My name is Ahmad Zaim, and today I would like to explain about the week 10 tutorial question number 3, linear regression with regularization. So here is our training dataset with 5 points. So we will use a high order polynomial consists of theta 0 until theta 4. One of the major aspects of training the machine learning model is to avoid overfitting. The model will have a low accuracy if it is overfitting, so we add a regularization term here. And inside the regularization term here, we have a lambda. So lambda is the tuning parameter that decides how much we want to penalize the flexibility of our model. The increase in the flexibility of a model is represented by increase in its coefficient, which are theta 0 until theta 4. And if you want to minimize the above function, then these coefficients needs to be small. So when the value of lambda is equal to 0, the penalty term has no effect. However, as lambda is close to the infinity or increase to the infinity, the impact of the shrinkage penalty grows and the coefficient, which are theta 0 and theta 4, will approach 0. So if the value of lambda is used, such as 10,000 for instance, the value of theta 1, 2, 3, and 4 will be heavily penalized and ends up the value will be close to 0 till a point this increase in lambda is beneficial as it is only reducing the variance, hence avoiding overfitting plus without losing any important property.